We're asked to rewrite this quantity using this property of logarithms. This property of logarithms is true as long as m and n are positive numbers and a does not equal 1. So in this particular problem, instead of a base a, we have a base b. But we can see what this says. We have something in problem 29 that looks like this, and we need to rewrite it as something like this. And so we have the log base b of a fraction, and the fraction is this number on top and this number on the bottom. And of course we know about 36 divided by 4. It's the same thing as 9. So this and this are exactly the same according to this property of logarithms. So the logarithm of a quotient, because a quotient is what you get when you divide, is the same thing as the difference of the logarithms of the numerator and the denominator in that order. The logarithm of the numerator comes first and the logarithm of the denominator comes second. Here's problem 41. We're asked to use our quotient rule for logarithms and our product rule for logarithms to change the form of this logarithm into one that just has individual logarithms for x, y, and z. We're going to do that, but we're also going to use one other property, and that is this property, the power rule for logarithms. And so let's get started. We know that this can be thought of as the log base b of xy squared minus the log base b of the denominator wz cubed. And we know that this can be represented with the log base b of x plus the log base b of y squared. Here on the first row we used this property, quotient property. Here in the second row we're using this property again and again and again. So notice the parentheses. We have log base b of w plus log base b of z cubed. But now we're only supposed to use log base b of x and y and w and z. No y squared, no z cubed. So we have log base b of x plus, and using this property here, we can bring this 2 down and we have 2 times the log base b of y minus, in parentheses, log base b of w plus, again using this property, we bring the 3 down, 3 times the log base b of z. And that's a pretty good answer. I would probably accept that answer, but to show you the importance of the parentheses here, if we distribute the minus sign through the parentheses, we get the log base b of w minus 3 times the log base b of z. Notice if we hadn't used the parentheses at all, this would be a plus sign and we would be wrong. So we are subtracting off this entire thing, and that's worth thinking about. There's our final answer. In problem 51, we're asked to go in the reverse direction. We're asked to use those same properties that I had on the last problem to rewrite all these separate logarithms as a logarithm base b of one big thing. So we're going to kind of do things in the reverse order. So we know that this first logarithm can be thought of as log base b of w squared minus the log base b of z minus the log base b of y to the 4th. So we have the log base b of w squared. Well, let's write it differently than that. We're going to have the log base b of, and now I'm imagining a fraction with w squared on the top. That's going to give us this, and z times y to the 4th on the bottom. That's going to give us these two subtractions, because remember, when you're taking the logarithm of a quotient, it's the logarithm of the numerator minus the logarithms of the denominators. So We've ended up with a correct answer. We've gone the other direction and we're done. These kind of problems are little puzzle problems where they do a very good job of quizzing what you know about the properties of logarithms. And the idea is that you have to understand those properties, but the actual work on these problems are not too hard. So let's take a look at this problem. We're supposed to answer this question given these two pieces of information. We're supposed to assume these are true. Notice in this problem, it's not necessary to find out what B is, and trying to find out what B is will lead you down a wrong path. Instead, we ought to use a property. So let's use the property that I've written earlier. I don't intend to write it again. That the log base b of a quotient of a fraction is the log base b of the numerator minus the log base b of the denominator. And we know that this is a given. It's 1.161. It's given in this problem. But what is the log base b of 1? What is the power you have to raise b to get 1? And the answer is 0. b to the 0 power is 1. So the log base b of 1 is just 0. And we have 0 take away 1.161, which is negative 1.161. The arithmetic is simple. It's easy. I didn't even really need a calculator for it. But the idea is kind of tricky. You have to understand those properties really well. So these problems, 59 through 68, starting on page 810, you can kind of think you're going to get something like one of those on a test. They would be worth studying carefully.